Alright, so transition metals, these are the ones that are all the orange ones here, and these orange ones here are also considered transition metals. I'm only going to deal with these ones today. These ones we'll deal with separately tomorrow. So this is called the D block sometimes, and that's because these are the ones that end with d orbitals, like this is 3d1, 3d2, 3d10, and these are the 4d and the 5d, so we call it the D block sometimes. D block. This group has most of the metals that you know of, the everyday metals: iron, copper, gold, silver, the ones that you've heard of before, nickel, chromium. All right, let's do physical properties. Okay, so good conductors of electricity. These first two are really part of the definition of any metal. Metals generally have this extra electrons on the outside that are kind of very loosely tied to their atoms, so they move around easily, and that's what allows electricity to flow through the atom really well. Because electricity is just electrons flowing, right? So it's really electrons jumping from one atom to the next, and they kind of all move in unison and jump along onto the next atom. So electricity flows easily if the electrons are loosely bound. And then for the very same reason, they conduct heat well. Because those electrons are loosely bound, they can get knocked around easily and sped up easily by any heat source. So these two usually go together. Many are malleable. C2.5. Hey. Okay. This works.
I thought he was pointing at me.
Malleable means they can be hammered into thin sheets. So some metals you can make really thin, like aluminum foil, stuff like that. Platinum you can hammer into thin sheets, which is useful if it's really expensive or if you don't have a lot of it. The opposite would be something like glass or plastic, right? You can't hammer a piece of glass into thin sheets, it would just shatter. So malleable, we'll do that. Let's see. They vary in how hard and brittle they are. Hardness, you know. Brittle means do they shatter or not. So some metals shatter and some metals do not shatter.
You spelled very wrong.
You forgot the Y.
Vary.
Oh, no.
What?
It's not vary. What did I do wrong?
There you go.
Vary.
Yeah, maybe
Oh,
they're
that's
hard and brittle the R.
They vary in how.
Hard
They.
and brittle the R.
Hey,
Yeah.
man.
Thank you. Okay. All right. Most of them are ductile. Supposed to be a C. Ductile means they can be drawn into wire. Not all elements or substances can do that. They usually have high densities. You think about the other ones we were doing, the alkaline metals, the alkaline earth metals, they're pretty low density. Some of them even, I think some of them float on water, I'm not 100% sure. But these ones are pretty high. And high melting point.
Exactly.
I have no idea if this is yesterday. I can check and
I know about
If you want, I can check on the screen. Okay. All right, that's it for physical properties.
Chemical properties now.
Yep. Remember with these, this is a really big group here, so not all the property I give you are going to apply to every element. Because here we're talking about 40 elements roughly. 40? Yeah, 40. All right, let's see. So most have 2 valence electrons. Okay, this isn't always true. This is like a general rule that's just easy to remember, so that's what we're going to go with. So let me go over the periodic table one more time. Group 1, the alkali metals and hydrogen, I told you all have 1 valence electron. Group 2 all have 2 valence electrons. And then everything from here all the way over here to this column here, number 12, the zinc, they all have 2 valence electrons also. Or that's what we're going to assume. It's not every single one of them, but it's most of them. So from here over to group 2, 2 to 12, all 2 valence electrons. And then 3, 4, 5, 6, 7, and 8. So each group number after that is how many they have. All right. Much less reactive. Than alkalis or alkaline earth metals. So these ones in the middle are kind of boring. Some of them react with certain things. A lot of metals will react with acids. Some don't even react with a lot of the acids we have. So generally they're pretty stable. We'll leave it at that because I want to talk about that. If they do ionize, they usually form cations. And in general, metals will usually form cations. Because metals are usually going to give up some electrons, and so they're going to have a positive charge. Non-metals usually form anions. Some do oxidize when exposed to air or water. For example, iron, Fe, right? You know, iron that rusts, copper corrodes. So, and this is slightly off topic, but these two are a little bit different. With iron, what happens is once it starts rusting, it'll rust faster. Once you have a little bit like some starter rust, it just gets it going. It's like a disease that spreads very fast. Copper, so with iron, you know, you have to get rid of it. You have to like sand it off or whatever, and then paint the metal or whatever you want to do. With copper, it's the opposite. With copper, it'll start to corrode and it turns green, right? Like the Statue of Liberty has a green outer coating. And once that coating is formed, it actually prevents rust. That coating like seals the iron on the inside, and then no more corrosion happens. So copper will actually stop corroding on its own. Let's see. Others, such as AU. What's AU? Gold. And PT, what's that?
I'm about to say potassium.
Platinum.
Yeah.
Gold and platinum are relatively inert. What does inert mean? They don't react. They generally don't react with hardly anything. And that's one of the reasons they were good for currencies, right? Because they last a long time. They don't corrode away like iron does. You know, if you're making a currency 1,000 years ago, you wouldn't want to use something that gets used up or destroyed easily. So gold, platinum, silver, all the precious metals generally last a long time.
That's because they were made last when the sun was
Well, everything over really hydrogen was made from the sun that exploded.